the previous video, we talked about different types of data and the importance of considering what to collect to meet project goals. Now, let's talk about the tools and equipment used by citizen scientists to collect data. Technology has made citizen and community science much easier, more accurate, and accessible to many more people. Some simple strategies for collecting data for citizen science projects might involve using cell phones to collect photographs or mark points on a map using geolocation, taking measurements with inexpensive or build-it-yourself sensors, making observations and entering them into an app or simple web form. After you've decided what type of data are needed to answer your question, you'll need to consider what technologies or equipment to use for data collection. Make sure the collection strategy you use is within your budget and also easy for citizen science volunteers to use. This increases the likelihood that volunteers will remain engaged in the project and that the data they collect will be useful. Sometimes simple solutions are best. For example, Crowd the Tap, a project based at North Carolina State University and funded by the U.S. Environmental Protection Agency, uses a simple method to promote access to clean drinking water. Citizen scientists only need a magnet and a coin to determine materials used in home water pipes. No fancy equipment or complicated instructions are needed. In the previous module, we introduced you to Clarice and Sean. Let's explore how they might identify the equipment and technologies needed for their projects. Clarice continues to work on her Healthy Foods project, and Sean is developing a project to address noise pollution in his community that he calls the Quiet Community Project. During the planning process, Sean and his team made the logical decision to use a sound sensor. However, they need to figure out what equipment will be most appropriate and how to obtain enough sensors at low or no cost to make the project work. Clarice needs to determine the best method to collect data and the information needed to answer her questions about access to healthy foods. For Clarice, this might mean developing a simple web form using Google Forms or other free or low-cost form software. For a small project like hers, paper forms could also be an option. Now, let's introduce a new citizen science project organizer, Maria. Maria works as a community outreach specialist for an extension program connected to a small rural university. She's been asked to start a citizen science project as part of her job. To determine the needs of the community, Maria recruits college students to survey local residents to better understand their environmental and health concerns. Many residents mention a river that runs through town that was formerly a popular place for swimming and fishing. Due to flooding and agricultural runoff, recreational activities are now risky and strongly discouraged. Maria sees an opportunity to involve the community, with help from local experts, in learning about water quality, collecting data, and communicating with local and regional agencies. The project goal is to convince local leaders to improve regulation of waterways, decrease health risks, and restore recreational activities. Maria names the project Pure Waters and forms a small planning team that includes town residents and university volunteers. She's not a trained scientist, but her connection to the university allows her to get advice on strategies and data collection for managing the project. In considering tools, she'll need to think about cost, how to obtain or build them, ease of use, and how to distribute equipment to volunteers. Because her project is regional, she's likely to have more flexibility than she would with a national or global project involving hundreds or thousands of volunteers. However, her funding and resources might also be more limited. Now, let's talk about some pros and cons for tools frequently used in citizen science. Phones have become an essential part of many citizen science projects. They can be a great option because so many people have them. You may not have a computer or Wi-Fi at home, but you are likely to have a phone. Phones are versatile and can be used to enter measurements, take photos, record sounds, record location with GPS, and so much more. And volunteers can collect and enter data from anywhere. However, there are a few limitations. Not everyone has a smartphone, so requiring them could exclude children or anyone who can't afford or doesn't want to own a smartphone. Also, apps and sensors that can be used with phones can cost money and require skill to develop. Simple web forms can be used for projects that ask volunteers to enter observations or measurements, like Clarice's Healthy Foods project. Free, easy-to-use tools like Google Forms can be used to enter data and can be accessed from a computer, tablet, or phone. For volunteers without easy access to phones or computers, paper forms can also be an option. For some projects, equipment will be needed to take measurements or collect samples. For example, Maria needs to find an easy way for volunteers to collect and test water samples. For Sean's noise pollution project, equipment is needed to measure sound. Some sound sensors even connect directly to smartphones. Geolocation uses technology, such as a cell phone, to accurately identify specific locations on a map. For example, for Maria's Pure Waters project, she might want to map exact locations that volunteers collect water samples. This would be important if she wants to determine if pollution is higher in some areas than others. In Clarice's Healthy Foods project, she decides not to use phones for photography or geolocation, since those would require a smartphone or other equipment. However, these options would be highly accurate for mapping store locations and visually recording quality and quantity of foods. Now, let's talk about where you might find the technology and equipment needed for a project. Your options will depend on the size of your project, the expertise of your planning team, and how much funding you have available, if any. The Citizen Science Hub, SciStarter, has compiled a citizen science tools database that can help you find low-cost equipment, apps, and other technologies. It can also be helpful to browse projects in SciStarter and other citizen science portals to find out what data collection strategies and tools have been used in similar projects. For small projects, some public libraries check out citizen science toolkits, including kits for measuring air quality, light pollution, and stream mapping, to name a few. Government agencies and non-profit organizations can also provide support to citizen science projects. For example, the U.S. Environmental Protection Agency provides access to air sensors and other tools through the Air Sensor Toolbox program. Likewise, Public Lab is an organization that formed after the BP oil spill disaster. They provide community support and inexpensive kits for analyzing samples, monitoring air quality, and other purposes. For the Pure Waters project in her rural community, Maria begins by talking to a specialist in the biology department at the university to learn more about the testing options for measuring water safety. Maria also searches SciStarter, Zooniverse, and other citizen science portals to find projects similar to hers to learn more about collection methods. She identifies several water sampling and testing tools that are inexpensive and easy for volunteers to use. It's important for her to test this with her volunteers to ensure success. Maria's Pure Waters project can truly be considered community science. By connecting with the regional university, community residents, and local agencies, she increases awareness of the project and benefits from the community's expertise. A best practice in citizen science is ensuring that projects are collaborative and inclusive. In this section, we'll talk more about best practices.